This video is going to talk about the science behind why the Earth has seasons. When you're done watching the video, I expect you to be able to tell us why the Earth experiences different seasons, the familiar spring, summer, fall, and winter that we see every year. So there are two characteristics that we're going to be using to define a season. The first one is the average temperature. Is it hot? Is it cold? Is it somewhere in between? And then the second characteristic is the length of the daytime and nighttime hours, because it does change. There are times where we have more daylight hours in the year, and there are other times of the year where we have less daylight hours. There are also some places in the world where our seasons are better defined by the average rainfall because the average temperature and the average daytime and nighttime hour length doesn't change. But we're going to be focusing on these first two in this video. So there are two things that cause the seasons: the Earth's position in space and the Earth's revolution around the sun. And I'm going to talk about each of these individually. I think you already know that the Earth rotates or turns around an axis that's formed by an imaginary line that runs between the North and the South poles. And one rotation, one turnaround, takes 24 hours, and that's what gives us our day and night cycle. Because, of course, as it turns, sometimes part of the Earth is facing the sun, which gives us our day, and other times it's facing away from the sun to give us our night. But you might not know that this axis, this imaginary line, is actually tilted. It is not straight up and down, but it's tilted 23.5 degrees off what would be perpendicular. This is a little bit easier if you think about it in a picture. So if the Earth was traveling on a table, we call this the orbital plane because it really travels it's like it's traveling on a table. It's flat in space. But here's our North Pole and our South Pole and this axis of rotation that the Earth is turning around. And you see that that is tilted. This would be perpendicular, and it's just off a little bit. That also is why globes, if you have a globe in the classroom, you see it is kind of tipped a little bit sideways. And of course, it's sitting on the table. That would be the orbital plane. And so this tilt is a very important thing about the Earth's position in space, because that is going to influence how the sun is affecting the Earth. So this tilt causes some parts of the Earth to receive more direct sunlight. It's more straight on, more intense. And this more intense sunlight will lead to higher temperatures. It's like standing right in front of a fire as compared to standing off to the side. In this diagram down below, the central ray, sun's ray coming in here, is hitting the Earth kind of in a perpendicular fashion. So this would be the most direct ray that is hitting the Earth, whereas these other two are hitting more on an angle. You can kind of see how the edge is on a slant. It is not as direct, and so the light would not be as intense in those parts of the Earth, and that's where you're not going to get as much heating as higher temperatures as you do in this one that is hitting directly. Along with rotating around its axis, the Earth is also revolving around the sun in an orbit. This orbit is mostly circular, and one revolution takes 365 and 1/4 days, and that, of course, equals a year. So you take the revolution plus the tilt, and what happens is that parts of the Earth that receive the direct sunlight will change during the year. And sometimes a particular part of the Earth, a particular hemisphere, will be receiving more direct light, and other times of the year it's receiving less, which then affects how much that part of the Earth is heated up, what the temperature is, and then what season is being experienced. So let's put together what we've learned about the tilt of the Earth, the position of the Earth in space, and the revolution of the Earth, or its traveling around the sun in the orbit, and analyze this diagram to see where are the four seasons in this picture. I want to start here on the far left, and if we look at our Earth, we see the North Pole is labeled and the South Pole is labeled, and here we have this imaginary axis that is going to be giving us our tilt. Also notice that we have the equator marked out, so it's dividing it into the northern hemisphere and the southern hemisphere. And if you notice on this diagram, the amount that is being sunshine is going to be lit up in the northern hemisphere is a much bigger piece than the piece in the southern hemisphere. So this is telling us that when the Earth is in this position and this place in space, more direct sunlight is going to be striking the northern hemisphere because it's oriented, it's sort of turned a little bit more to the sun because of the tilt. And so if there's more direct sunlight, that means more heating, and that means higher temperatures. And so this is a picture of what the Earth looks like in space during the summer season for the northern hemisphere. Because, of course, the southern hemisphere, the bottom side of the Earth, is not receiving as much sunlight. We just have a little bit of sunshine showing here. And so in the southern hemisphere, it would actually be winter. So our seasons between the northern and the southern hemisphere are always opposite. Going over to the right-hand side, to the other side of this orbit, we have the opposite thing happening. Of course, here's our tilt, and we can see our southern hemisphere now is oriented more towards the sunlight. It's going to get more direct, more perpendicular light rays than the northern hemisphere. In fact, our North Pole here is in darkness. And so this would be winter in the northern hemisphere. Oops, I got to spell right. And summer in the southern hemisphere. And then, of course, the other two positions are the seasons in between. So if we go from summer to winter, of course, this is going to have to be fall up here for the north, and then it would be spring in the southern hemisphere. And then our last diagram at the bottom here, our northern hemisphere is going to be experiencing spring as we move from winter to summer, and the southern hemisphere is going to be experiencing fall. So you see in this diagram on how the tilt of the Earth, which never changes, it's always pointing off in this diagram to the right, that tilt stays the same as the Earth moves around the sun. And so the tilt plus the revolution is what gives us the different seasons because it affects how the sunlight is striking different parts of the Earth. I also want to point out that the Earth's orbit is mostly circular, but it's not perfect because sometimes we're 147 million kilometers from the sun and other times 152 million kilometers. So we're a little bit closer at one time and a little bit further away. If we look at the axis at this tilt and think about the northern and southern hemisphere, this is going to be our winter time here in the northern hemisphere. They tell us it's the 3rd of January on this diagram, but that is the time that we are closer to the sun than over here in July when we're further away. Yet we all know that July in the northern hemisphere is a lot warmer than January. So it's the tilt, not the distance, that matters. That is what's going to determine what season you are in. And in the northern hemisphere, we're actually further away from the sun during our warmer months. So check your understanding. Can you explain how the Earth's position or its tilt work together with the Earth's revolution or its orbit around the sun to cause the seasons? If not, you might want to go back and listen to parts of this video again because this is an important science concept that you need to know.